Hi again everyone, Chris Tisdell here again. In this presentation I'm going to continue my series of videos on complex numbers. Now in particular I'm going to show you how to solve a quadratic equation that has complex numbers as coefficients. So we'll work through an example and let me share my screen with you so we can get down to business. Okay, so square roots of complex numbers and quadratic equations that have complex numbers as coefficients. Okay, so it's a two-part problem. We are going to solve the following problem first, and then we'll use that information in the second part. Okay, so we want to solve this z squared equals 15 plus 8i by computing the real and imaginary parts of z, which are assumed to be integers or whole numbers. Now, this simplifies some of the calculations, okay? And hence write down the square roots of 15 plus 8i, and we'll use that in solving this where we just apply the quadratic formula. Okay, so let's forget about the z and let's compute x and y. Once we know x and y, we have z. So how do we do it? Well, for part one, what we're going to do is expand this bracket and then equate the real and the imaginary parts. Okay, so let's expand the brackets. So when I expand this, I'm going to get x squared. I'm going to get yi all squared. Now remember, I squared equals -1. So I'm going to get x squared minus y squared. They're going to be the real parts. And you're going to get 2 times that, 2xyi. Okay, so the imaginary part would be 2xy. And that's got to be equal to 15 plus 8i. Okay, so two complex numbers are equal if and only if their real parts are equal, so that and that are the same, and their imaginary parts are equal. So that 2xy has to equal 8, or positive 8 over there. Okay, so if we equate those, we set them equal, we'll get two equations. So let's equate the real and imaginary parts to obtain the following. Okay, so we're going to get x squared minus y squared equals 15. That's one equation. And 2xy equals 8. Okay, so how do we solve these? Well, the nice thing now is that because we know x, or we given the knowledge that x and y are both integers, are both whole numbers, we can actually start with this and say take the 2 to the other side. And then I can come up with potential values for x and y just by looking at the factors of 4. Okay, so factors of 4 are the following. Okay, so let's say 2 and 2, -2 and -2, 4 and 1, and -4 and -1. Now, we can't have all of those, but we can rule some of them out. Okay, let's put x equals 2, y equals 2 in there. You don't get 15. Same with -2, x equals -2 and y equals -2. You put those in there, you don't get 15. So those two can actually be scratched out because they don't satisfy that equation. What about these two? Well, if x equals 4 and y equals 1, you'll get 15, and same with -4 and -1. Okay, so if we apply x squared minus y squared equals 15, we see that x and y is 4 and 1 or negative 4 and negative 1. Okay, so there's going to be two complex numbers that satisfy this. And it's going to be 4 plus 1i, or just 4 plus i, and negative 4 minus 1i, or negative 4 minus I. All right, so these then are the roots of 15 plus 8i. Okay, so that's the first part done. So let's go and see if we can solve the second part. Now, the second part is just looking at a quadratic equation, which you have seen quadratic equations at high school. But this one has a twist. You are using, you have got coefficients that are complex numbers. Okay, so we've still got it in the form a, say, z squared plus bz plus c equals 0, but b and c are both complex numbers here. A's are just 1. What we're going to do is apply the quadratic formula to solve this, and actually the square root sign that we're going to get is going to be the square root of 15 plus 8i. So we're going to use part 1 to solve part 2. So let me show you how that works. So we're going to apply the quadratic formula that we all know. Okay, we know that z is going to be negative b plus or minus the following square root all over 2a. Okay, so b in this case would be negative all of 2 plus 3i. A would be 1 and C would be negative 5 plus I. So if you put those in here, you'll get the following. So the negative will cancel out. Okay, B squared, that's going to be this. Minus 4 times that times A, and A is 1. Okay, I just squeezed it in. All over 2A. A is 1. Okay, now this is a bit of a mess here, but if you expand this out, you will get inside that square root sign 15 plus 8i. Now I'm not going to put the details in. If you want to fill them in, you can yourself. Okay, so now because we've computed the square roots of 15 plus 8i in part I can actually write an expression down for this. Okay, we got them to be this and this. I've already got the plus or minus there, so I'm going to replace the square root with just say 4 plus I. So that's from part I, or part 1. And I get this now. So now all I've got to do is simplify, okay? So if I use the plus sign, I'm going to get 2 plus 4, which is 6 plus 3i plus I. So I'm going to get 6 plus 4i all over 2. So if I divide the 2 in, I'll get 3 plus 2i. And if I do the negative sign, 2 minus 4, so that'll be negative 2. All over 2, that'll be negative 1. And the 3i minus I, that's 2i all over 2. That'll be plus I. Okay, so the solutions to that quadratic equation are given here. Okay, so a couple of remarks, right? If the if you don't know ahead of time that x and y are integers, well, you can actually introduce a third equation here. You basically take the modulus of both sides of this and then use properties of the modulus to get a third equation involving x squared plus y squared. And I've done those kind of examples in other videos. Now, especially if you're asked to use part 1 in part 2 and you get down to, say, here and you don't have that, you'd want to check your calculations quite carefully. Also, there is a quicker way of doing part I using a special form known as the polar form, but we haven't covered that yet in this series of videos, but we will. Okay, so that's my presentation. Hope you enjoyed it. If you want to post a comment or give me some feedback or some suggestions, I'm always very, very happy to receive your comments and your questions. So please join me for the next presentation where I'm going to continue my investigation into complex numbers. Thanks for watching and hope you can join me again. Bye.